I'll go ahead and get started. So the session is being recorded. Everybody will get an email following this as well with the recording. But I wanted to review today um, organizing your company in a cloud-based system. So we're running this series on how you can think a little bit differently when running your design platform in a true software as a service cloud-based architecture that doesn't require things like C:\\/ file servers, check in and check out like a Vault would. All these things are now different because you can now do things differently in a software as a service type platform like Onshape has. But we'll go through and kind of understand why systems have been designed in a way that they were over the years, as well as talk about how you can change to a newer workflow and not be married to the older style ways of working with files. So if you have any questions at all during the webcast, feel free to use the chat box or the questions panel during this presentation. So let's get started. So let's review the agenda really quickly here. We'll talk about, like I said, common organizational practices in use today. Your Windows folder system, your Dropbox, whatever you're using, a PDM. Then we'll talk about how you would do things a little bit differently in Onshape using the software as a service platform capabilities through a demonstration. And then, kind of come back to, some of the tenets of Onshape again. But let's take a look at this picture, okay? Now, if you're old enough, you may remember what this looks like. You may have been here. I was just on the tail end of it. I started my engineering career on a drafting board in high school. And I loved it personally. I loved being able to draw things and work on a piece of paper and be one with it. Of course, you can't. I mean, we built battleships and sent men to the moon, of course, without the 3D CAD systems. But we can obviously do a lot better today with the technology that we have. And if we look at this picture very, very closely, okay, have things changed that much? Let's think about this just a little bit. If you take a look at this, you know, let me go back here, one slide here. If you think about this, each one of these engineers is working on their own on the original quote unquote drawing that was taken out from the drawers here that the document control person allowed the engineer to take. And of course, a document control person is making a copy on the ammonia laden blueprint machine and putting that copy back in the file drawer so they have all the old revisions. You have the engineering manager here, kind of talking, to the engineering secretary. Of course, we don't have those anymore. Everybody has email and they manage their own personal agendas and schedule today. And then the work is then distributed, by the engineering manager to the rest of the team here in this drafting room, right? So are things that different, right? Let's think a little bit more about taking those blueprints, those D-size pieces of paper with various parts being drawn on them, and equate them with files, right? Here's a pretty traditional file structure that you might find in a CAD system with a top level assembly of a machine, some subassembly files, some part files, of course, that make this up. Of course, there's drawing files as well that then report up. So this is very, very similar to each part in each assembly having their own blueprint, right? Think about it. It's true. It's essentially, we just duplicated the drafting room in the modern file-based world. We think of working in this modern approach. We have awesome 3D CAD systems. We have awesome computers instead of drafting machines on our drafting tables. And we, instead of file cabinets, we have file servers. And if we're lucky, we might have a database that's kind of taking care of things, like the document control person, knows to say, okay, and Ed the engineer took out this file at this point in time, and he made these changes and puts it back in the database. If you have a PDM or PLM system, is doing that. But of course, when you're working in this approach, no two people can be working on the same file at once. Now, in fact, back in the drafting board days, you could actually have multiple people working on the same piece of paper at once, right? If you really think about it, if you had enough room on your drafting board for two people to start drawing on different parts of it, that was quite rare unless it was a big, long, wire cable harness drawing or something like that. I've seen that done in the past, but we really haven't progressed, have we? It's kind of weird to think about, but it's true. So, just think about that life of one file for a minute, and then we'll get into how you would organize yourself in Onshape, because in Onshape, we wouldn't really think this way, okay, because we don't have to anymore. So if you think about the life of one file between a team of 4 engineers that would interact with that one file from this tree of files that we're looking at, everybody has a copy of their own CAD system. Everybody has a copy of a CAD file, and they transfer it in different ways via various file copying mechanisms, whether it be email, cloud drives, thumb drives, hopefully not, and file servers most commonly. 60% of all the people that I talk to here at Onshape don't have any PDM system at all. They're just using normal file servers on their network. If they're a younger company, they might be using a Google Drive that synchronizes the files. If they're a company that's multi-location and has a couple of different sites and maybe more than 5 or 10 engineers, they've probably invested heavily in a PDM server that manages the copy process and keeps track of where those file copies are going. But of course, that PDM system is very much like that photo that we just had on the screen before. And these tools are not anything new, right? That even the things that are being put out there as quote unquote cloud-based systems, they're still kind of file centric. Only one person at a time can work. There's actually installed software here, there, and everywhere. So these tools actually constrain what you can do for concurrent engineering, working together, which may or may not be a problem to you right now. But people that are taking advantage of concurrent collaboration systems like Onshape are actually able to get ahead of issues sooner. So, issues like this, right? If we think about it, if we have this file copy based approach and you send a design change or you're working on a design change after you've sent out some files to somebody else to start cutting metal and stuff, everybody has seen this kind of email. This is not something that would happen in a live simultaneous PLM CAD system. But of course, it would happen every single day in a PDM system or a local Windows file server, etc. And as we discussed in the previous chapter of this series, back in a few weeks ago now, we talked about concurrent design processes. The older systems that are based on files, which only allow one person at a time can work, will end up costing you higher amounts of money and time the longer it takes to find a design problem. Okay, so if you can find that problem earlier by interacting, working together, you're going to be able to reduce that cost of change and cost of delay, which is a metric that many, it's a KPI, right? That many first-class companies are measuring nowadays. So people have been trying to build a real-time PLM CAD system, but I think they've been missing the mark if they think they can actually put the files in the database in the cloud and keep the CAD system local. Even the most modern systems that we compete with every day are just moving the file-based problem to a cloud container, right? It's not really a real-time collaborative environment like Onshape is. So people that want live real-time analytics and information aren't going to get it from that previous slide that we just looked at right here, right? If we really think about it, how can Mike, the manager, up in the front of that drafting room know what Ed, the engineer, is doing? Because quite often they're not in the same room anymore. There might be a customer site. They might be at an office across the country. Of course, they can get on a Skype call and talk to each other. But it's not up to the minute information like most other business systems provide today, like a Salesforce.com, Jira for software management and development. Things like that are real time. You get dashboards, analytics, information about what's going on in the business of your company. All the other departments in your company have these tools, except for the most important department in your company, the engineering department, that is the lifeblood and engine that's driving the company. It's kind of crazy that these tools haven't been invented yet. Until now, of course, we have Onshape, so you can get that real time information and work together collaboratively real time. So Onshape does more than just CAD, right? It is the data management. It provides a new paradigm for design, practice, and workflow, which is really what I'm going to get into today. Like, I'm not going to talk about how to draw lines and arcs, but I will be talking about how to organize those parts and assemblies that you're creating in a way that is conducive to collaboration, real-time problem solving. So let's actually hop into it just a little bit. We'll build some piece of machinery, at least a piece of it. This is kind of the end result right here of this particular design, machine design with some robots moving along these rails here that are going to pick up these little parts. Part interchange is important in this particular demonstration. We need to have small, medium, and large widths of these little carousel carriers here that we're going to be working with for different parts that are going to be picked and placed. And we need to design it for different markets. Maybe you're going to have different types of motors in the EU versus North America. So the power cabinet's going to change. There's going to be different parts in it, different types of wire, connections, things like that. And of course, when you're designing this type of machinery, it's always very fast lead time stuff because you have the product manufacturer or the product design that's going to be in need of a machine to automate the assembly and assembly process. So these types of projects need to be done very quickly. So we'll work between several different engineers during this demonstration. Mike, the manager, Debbie, the designer, Ed, the engineer, and Emily, the electrical engineer. So let's hop out of the slideshow for a minute and actually go into CAD PLM land here inside of Onshape. And of course, I can jump in, to the actual machine design itself. Of course, we're in a web browser, just Chrome here on my MacBook computer. And you can see that I'm opening up multiple tabs, right? I have the main documents panel tab. I have an activity tab to kind of show what's going on as a lens of information into what's going on at my company. And I can see right here, Mike, the manager, just opened up the indexing machine design document right here, and I can see a list of his activities real time. So I can understand what is actually going on, right? So pretty cool to see that. Then we have the documents page. Then we have the top level machine design, which I just pulled up right here. And of course, as I move this around here, we can see the actual machine, working. I have this cam mechanism that's moving these plates back and forth, like here. And of course, once a part moves over, this robot might come over, pick it up and grab it and put it in a bin somewhere else right here. So how would I go in and design an Onshape knowing that we don't have to worry about file management per se? So what I'll do is I'll start a document for this machine design right here. I have a little bit of it started for the ease of demonstrating what we're going to do. This is an Onshape document called this 2020 machine design. If I look at it, there's several tabs in it: top level assembly, a frame assembly, several part studios for different types of operations. you might do this in several different documents that all report up to one another, of course. But for these three basic pieces, these are the unique pieces for this particular machine that I'm going to keep here together in one document. Of course, you would not do this kind of thing in a file-based system. And the reason is because only one person at a time can work in one file. So on this base station part studio that I'm working in, if you wanted two people to be working on this, one person might be working on this piece of rail right here, and another person might be working on this piece right here for this end fixed piece that I'm working in right here. But in Onshape, we don't have to do that, right? Because the file is not the atomic unit in Onshape. It's the database is keeping track of things for us. I'm creating two parts right here. You see this part list being generated here. It keeps track of all of the different parts that are being made inside of the system. So that's two different parts. And, as me, Mike, the manager, who have signed in right now, I might start this design and then interact with some of my other colleagues to help work on this. So if I add a comment to this surface, inviting my colleague Debbie to help me with this, how to attach this to the frame, I'm going to ask her a question on how to do that. I can ask her that question. I can assign her a task. That'll be a future discussion that we have in the system to actually go in and manage all the tasks and processes here in my company. But I'll assign that to her now. She's invited to work in this design in a view-only fashion by default, unless she already has some other kind of access built in already. And let me just go in and open another window as a second user right here. So I'll sign in as Debbie, the designer. So I'm putting, changing hats, if you will. And as you can see, she has been shared in to this particular design right here. If I look at the share settings, it's actually in a project. So let me just share her in like this, give her view only access, view and comment, right? If she goes to her document list, she will have access to the machine design project and be able to jump into that design with me. And now we're both looking at the same information simultaneously, and we can work together in one document instead of having to split these out as multiple files. Now, let's think about this again for a second. Why is this even important? Why is it cool to have multiple people in one document and design these parts together? Well, look at this. We have a layout sketch, right? This layout sketch is very nice because it's like an engineering notebook or even a napkin sketch that describes parametrically how this system should come together. I did not have to do any kind of fancy assembly in context modeling, didn't have to do any kind of weird skeleton type modeling. In fact, all I did was just sketch out what I wanted for the shape of this design, and that makes it easy to go in and start establishing different parts inside of here. And because Onshape's database-driven nature and it not being file-based, locking up these files, I can then go in and propose edits, modifications, reply to comments that have come in. Debbie might say that, a socket head cap screw may be appropriate, right? So that conversation is happening live inside the document. But more importantly, as Mike starts making changes to the design, and we'll just split our windows up here so we can see what's going on a little easier. I'll turn off these planes and I'll turn off this layout sketch so we can see even more clearly. You can see, of course, that's updating on Debbie's side of the screen. I can go in, create a sketch, and offset some of these geometries that we're looking at right here. Okay, so let's go in and add that feature to attach a socketed cap screw. Of course, we need a hole to place that. So I'll just throw in an offset on this particular surface, in locations where it might make sense to have a socketed head cap screw in place somewhere. Maybe we'll do 3/8 of an inch. And I'll place that hole inside of the design using the points on the corners, of that sketch. We'll call it out as a M5 socketed cap screw hole for counterbore. And now we have that. And of course, Debbie is seeing that update straight away in her design. And of course, she has access to this design. She's a member of the project inside of here. Now, she's actually a member of the engineering team, so she doesn't actually have to have any special access. I could actually remove access like this because she's a member of a project. She already has the edit permission being an engineer in my company in this particular project folder. So I could even remove that, and she has the ability to edit this design right here. And she might know that this hole right here doesn't need to have, holes on this corner and this corner here. Mike can even see that Debbie is making that design change live and in real time. And as soon as Mike or Debbie hits the OK button, we're seeing that update live again. So the other part of organization in an Onshape kind of cloud-based approach, and I'll just accept that right here, is that the names of the parts can just be set on demand. You don't have to go file, save as, C:\/ this or that. You're just going to say this is the rail just by naming it as such, and then this is the fixed plate, right? So that's the two parts that I have here at my fingertips. And if anybody else in the company wants to find a part called rail in the system, I'm going to say I'm looking for a part. Its name happens to be rail, and I can search the database to find the rail in my company. It's going to find it because it's a real life database driven object here. And you can see right here at 11 a.m. Here, right, is when I originally made one of these rails. There's more rails being, popping up here as we go through here. And then this rail will pop up in just another minute. So it's really pretty cool that you don't have to know where that part is. It lives in this document, but I could use that rail somewhere else if I really wanted to, which is great. Now, and of course, I renamed these parts with other people looking at this at the same time. Everybody knows this would be a complete disaster in a file-based system. Renaming parts while other people might have other copies of parts opened up causes all sorts of problems, which that would never happen in our system. So we're able to create these parts together inside of the design without thinking of file management. That's the big thing I want you to take away from this so far. Now, other ways of organizing your information are to bring these into assemblies and start referencing in things from your libraries of information that you build up over time, right? So, if we were to go to an assembly that I happen to have right here for the base station, a blank assembly, and I insert the two parts that I've created so far into this assembly. I have those two items, right? I have another item on the other side. And I need two rails essentially to keep this together. So I'll just make a copy and a paste of that particular rail. This part is fixed in space, of course, the fixed plate. I might group this and this together because that's how I modeled them. That's one way of mating parts inside of Onshape. Another way of mating parts inside of Onshape is to fasten the components together at appropriate datum points. So I'm going to take this corner and match it to this corner right here. There we are. And of course, maybe I need another plate on the back that's not fixed. I will continue to do that as Debbie, going back to that layout sketch, taking this piece out, hitting the extrude command again, going up to this face, right? And then, naming it appropriately, of course, the moving plate. And I would insert the moving plate right there. It pops into place automatically, but of course it's not really mated in place. I would need to add some sort of mate to it, so I'll just add something called a slider mate to take this surface here and put it on that surface in the center as well, matching it up. And now we have the ability for this to slide back and forth, and it adds one mate. So you can see organizing your assembly is also much quicker and more effective and less work. I can even set the limits of this slider mate to go between a certain range of motion, here, right? So I can just, set that so it only moves between 0 and 6. Looks like 6 is a little bit short for that range of motion, so maybe we need to make the rail bigger. So Debbie is going to make the rail bigger. Maybe a comment is thrown in by Mike asking her to make the rail bigger. So she can go in to this design to make this go from 7 to 9. As soon as she hits the OK button, we're going to see that update in the assembly, of course. And now, we have a part that's not going to fall out of this channel, that I've developed right here. So that's another way of seeing how quickly you can interact with one another. You didn't see any file save as, check-in kind of operation. Everything in Onshape is recorded as an item in the history. Think of this as like a bank statement where you see all the transactions on your card. In Onshape, you actually have a listing of every single transaction that's ever occurred in the design. We're not creating file copies on a server somewhere. It's the database that knows how to reconstitute the model at any point in time. I can even compare one moment against the other to see what the differences are between an older moment in time and a newer moment in time. If I go to the part studio right here, we'll see the change occur, showing the new length added, to that particular piece of rail right there. And of course, in this timeline view, we could label versions in time as well. So I'm going to check the questions panel right here. Quick question of using a motion controller like a 3D mouse or something. Yes, you can do that. 3D Connection motion controllers have Onshape drivers available. You just need to update your driver to the latest version and it should work. Next thing I'll do is just create a labeled version in time. Right here, I'll set this at version 1. So that way I can keep track of major developments along the timeline. Right here. So that's version 1 in our timeline. We can even try out different design alternatives now with this unique timeline-driven approach. Instead of doing a save as copy, yet making more and more and more files, Onshape allows you to branch to create different design permutations and ideas. So this might be the, this one might be design for manufacturability, and another one might be a branch for the sizing of this, right? Remember, we wanted to have different sizes for different reasons, for different parts that might interface in this design that we're looking at right here. So let's do that. On the sizing branch, I'm going to go in and create a couple of sizes using our configuration manager on the side of the screen. I'll add an input for maybe device X, device Y. Let me just do it this way, copy and paste. Copy that. Paste that. There we are. Device Y and device Z. So now we have these 3 devices, which I might ask a question, which device First day typing, I guess. Here we are. Excuse me. And so now I have this interface, this menu showing me device X, Y, and Z. And then I can configure from one nice sketch, the dimensional information that I need to alter, right? Maybe this diameter I need to alter as well. So now I've built up a nice small table. We'll go from 2.5 to 2 3/4 to 3. We'll go from 7, 7.5 to 8. And then this length right here might be 9, 9.5, and 10. Now I've built up a nice little table that allows me to alter the shape to accommodate different devices that might go into here, right? So we did that as configured items. Now, organizing your company, I'm looking for these. I have these 3 parts that I've controlled using these 3 configurations. Of course, that's available in the assembly as well. But how would I organize myself? That's the focus of this discussion. I have these 3 plates that need to all be found and released and produced. So we have configured part properties, and this is where the CAD system kind of becomes a business system. So I have this rail, and I can add a property called name. Maybe I'll put the part number to SKU. I'll also show, let's see if there's anything else I want to show. Maybe not. I guess that's all I'll need. So for device X, Y, and Z, so I'll just go device X, Y. I have this other system height variable. Just ignore that. It was something I was playing with. Rail device X, right? I'm giving it a name. So this is actually the name of the part in the database. Device Y and device Z. And of course, look what happens immediately in the parts list. We're using the rail for device Z. If I go to the assembly over here, it's probably going to be X because that's the one I inserted the first time, and there it is, right? Of course, we can configure the assembly as well. Here's the bill of materials in the assembly showing the rail for device X, of course, right there as well. So everything is all up to date simultaneously. No need to save as, check in, check out, or anything like that. Of course, you'd have to fix a whole bunch of broken references doing what I'm doing now in other CAD systems. Let me go back to the Part Studio. So configuring the properties of the parts. I can even give these all different part numbers. So I just assign them all from our part number database, which you can configure inside the company settings of the Onshape system. And of course, you would just do this for each one of the parts, right? So you have the fixed plate, and I can add name, part number right here. I'll do 3 rows for that, X, Y, Z. And then the name would be set right here, device X, device Y, and device Z, because they're all different sizes. All right, so I won't keep on going with that. It's pretty clear now that you have all these parts. You can release those parts. If I go to the assembly, I can also match these things up. So you're organizing your assembly to use each of these different sizes, right? Device X, Y, and Z. So you go to the configuration tool here. I'm going to hide this one, add a new input, device X, device Y, and device Z. There we are. And of course, this is the, it'll be the same name as before, which device. And then to configure that, all I have to do is pick the part out of the list and tell it which one I want it to use. So I'm doing a mapping, right? Just mapping one field to another from the Part Studio to the assembly. And now I have device X, Y, and Z. And now I have assembly level configurations, just like that I can work with device X, device Y, and device Z. And of course, the parts are up to date right here. The mates all work, right? You could even configure the mate So if I go into the slider mate, I can configure how long that should be able to move. So maybe in device Z, it's going to be 6.5, and in device X, it's going to be 5, right? So now I'm in device Z, it can move further back than in device X, which should only let me move 5 inches. If I measure between here and here, it's 5 inches, right? So you can see how fast this is. This is just incredibly speedy design because you're not waiting for the baton to be passed from one person to another. It's instead of running a relay race, you're running the race all together in the time. It's just a way faster way of doing work. So, of course, the bill of materials is also configured and up to date with the available information. I can even generate the part number right from here, even set the name of the configuration right here. This is moving plate for device X. I actually did that from the BOM, but if I go to Y, you'll see it'll go back to just a regular name, and I'll call that device Y and device Z right from the BOM. So this is a live BOM that we can work with. Now, at some point in time, you want to stabilize this, right? This is like early on in the development process. We don't want to, have a complete free and open thing forever once we start going to quoting and manufacturing. And that's when you would go in and create a release package to stabilize it. So I'll take this assembly of the base station, create some sort of drawing of it. I might actually have a drawing ready to go. All I have to do is just load it up and refresh it. There it is. It's already partially done. There's my bill of materials, and I can show the shaded view, pull out a couple of sections, things like that. So I like the way this looks. Looking good. There's my BOM, and I want to release it. So I'll create a release package including all of the parts that make things up. And let's just, it's telling me I need a different part number. I must have used this from another design. So let me reset these. All right, so it's showing me right here all the things, right? All the parts, all the sub-assemblies that make it up. I can assign those part numbers straight away and give it an ECO number, which I usually just match to the drawing number. Oh, copy that again. Undo is your friend. There we are. And I can approve that. Somebody can approve it for me, like Debbie, and somebody can look out in the manufacturing department that this is coming down the line, and I can submit that for approval. So that's the release management process to stabilize that, as a labeled version in time. I've actually told it not to let me release it if we have a pending update on a drawing as well. So that is different, right? Now, if I go back to the assembly, again, maybe you want to also insert other parts from your libraries. Maybe you have a standard actuator, a standard library of different things. You can insert parts not from just inside the document, but from outside of the document as well. So if I go to my Onshape right here, of course, you can browse through any libraries that you've generated. Maybe I have some sort of automation folder where I have some markers or some hydraulics here where I can drop in a something that I've downloaded from a supplier like this. I can just go in and drop that component in, of course, to the design by browsing around my system for it. But we're in a cloud-based database. We don't really need to browse around for parts, right? I could actually go in and search for parts instead. So if I hit this filter button, I can say I'm looking for an assembly, or I'm looking for a part from a certain supplier. What's the supplier name? Well, it's going to be, let's look for SKF bearings or something, right? So I'm going to look for anything made by SKF in my system. I just do the search, and it will produce results. There's an SKF bearing right here, and it will ask me which configuration I want too, if there were configurations built in to that part. I'm looking for the 619 by 6, and I can actually use that particular configuration now inside of this design. It's actually configuring it on the fly. And this is just something I configured in my library. You can, of course, build up your own library any which way you want. I'll browse into my library here to show you what it looks like. Here's my library. I've broken it into different categories of things, right? So here's some hardware in my particular library, and I can use those parts inside of this design right here. Let me just drop this one in. I forgot to do that. And now I can snap that, of course, into place, wherever I see fit. I'll just fasten, the center of that, to the center of that. And of course, our bill of materials is now up to date, with that information. So organizing yourself in a system like this becomes much easier, right? You don't have to think about all the different places where files are being saved. That's the kind of moral of the story here. Let me just go back over here. So this version tree is really interesting, right? Because we're able to try out different ideas. We can merge ideas back together, which I think we showed you in the last webcast. We can search for released items, even if they're configured. They're treated with their own part numbers. They can be released as their own revisions. Some of the other PLM systems out there have a difficult time with configured type projects, and Onshape, of course, knows how to handle that. This also allows for this truly concurrent design process that we've been harping on right here, allowing you to work in a more simultaneous fashion if you have a design team. And then if you kind of remember what we started with, it really enables this real-time problem solving. This part studio concept is really the most effective way to author designs, that have, one part that lives, next to another part. You wouldn't build a whole airplane this way, but you'd certainly build the steering wheel of the airplane, which might be made of 4 or 5 parts that go together in one part studio. You see the assemblies, the way they work, both internal to the document or external. They provide a fast, frictionless user experience. You just snap the parts together, assign relationships, distances, motion, things like that. The release management allows you to work without locking people from doing other things. We'll talk about this in great detail in another presentation subsequently. And then, of course, it's very easy to share your product knowledge, both internally and externally, to other stakeholders within the company. So that's where I'm going to pause, okay? Just to kind of, I threw a lot at you guys during this particular presentation, so I want to make sure that you guys have time for questions. I have another presentation right after this. So give me, if you have any questions, I'm happy to answer them now in the next 5 minutes or so. And then, of course, we can schedule any kind of follow-up session too. So, you'll get an email following this. If you want to, get back to us and reply back to that email, we can help arrange feature Q&A sessions in the design. So I'll give you guys a few minutes. If you have any questions, I'm happy to answer them.